Ladies and gentlemen, it is my pleasure today to present past experience on my professional practice related to the structural engineering solution to the architectural challenges. Nowadays, there are more demands on advanced structural analysis and design to accommodate the current challenges on the new trend of architectural design. First of all, allow me to walk you through the fundamental principle used in the structural design process. From the structural perspective, there are three primary requirements to achieve in building design, namely, 1. Stability, 2. Strength and stiffness, and the third, economy. Both stability and as well as strength and stiffness would depict engineering safety. Of course, safety cannot be compromised. However, when building with free-form architecture, economy in design may have to be traded off with additional premium in the construction cost and time. In the structural planning and design process, architectural design means art of making forms, while the structural design is the art of proportioning. Good structural engineer or good structural designer will always have feeling for structure. However, he cannot use only engineering intuitive, but also architectural mind to achieve success and beauty in his design. Therefore, do not believe solely on figures or numbers from analysis, but also one has to consider the proportion. In nature, every object has its own structure. It can be linear, planar, or three-dimensional shell to meet the architectural configuration. Building must have its own structure, similar to the skeleton in human's body. This means that engineer is capable of doing structural design once he has a mathematical model for his calculation. So when we have to deal with the structural design of an irregular form, to define the problem statement clearly and completely is the key to the safe and sound structure. In the old days, the engineer has no other means or tools besides hand calculation in making precise structural analysis. This is, of course, the constraint in engineering design to cope with the liberty on free-form architectural design. At present, three-dimensional structural analysis software are available and widely used. This has given no limitation to structural design to cope with any challenging architectural forms. Besides the ordinary design criteria, engineers must be able to realize critical and vital aspects to cover a wide range of problem statements, such as structural motor failure, strength, and stability. Let's talk about structural motor failure. To me, it is very important. I will not design the structure which I do not know its motor failure. Sometimes mathematical model cannot predict the structural response of building correctly. So small-scale model testing should be carried out to verify the theory and the analysis results. Moreover, testing results can form up the input of design parameters. A good example will be wind tunnel testing for a very slender and tall building. Secondly, the fail-safe concept. It is not new in the process of structural design. It was originated in 1920 in the aircraft research. In principle, by simple addition of a member, a frame which suddenly reaches the ultimate load is changed into one which gives clear warning of collapse at a lower load, whose level can be controlled at will. One example is the rule in the ACI code which limits the amount of tensile reinforcement in a concrete beam to ensure a primary tension failure. Thirdly, design construction coordination. Engineer has to come up with the structural design that can actually be built. When architectural form is very challenging, construction technique would become part of our main problem statement. Structural design shall cope with construction technique at an early stage. Last but not least, strength and stability. It is very important to differentiate the strength from the stability when dealing with irregular form of architectural design. In many cases, building may satisfy the strength criteria, but not satisfy well in serviceability and stability. These well-defined problem statements can be illustrated by going through together in the following exemplar. The first example is the new Stock Exchange of Thailand headquarters on Ratchanabhisek Road. Building has curved columns, so computer-aided design and construction was required, and potential motor failure could be snap buckling of those curved columns. Composite columns were used to ensure ductility for strength and stability, as well as to prevent the snap buckling and ensure fail-safe concept. Prefabricated steel tube columns allow ease of column installation and precision in fabrication. Large-scale steel transfer beams were used to eliminate heavy shoring system, and mass pouring of concrete at a higher level of building. The second example, the G-Land Tower on Ratchadapisek Road. There are two towers on top of the same podium. The North Tower is 31-meter cantilever at the top, and the South Tower is 8-degree incline from verticality. From the aerial view, the complex view symbolizes the letter G as the logo of the developer. This building requires extensive and advanced precision of structural analysis to ensure stability, unlike the Leaning Tower of Pisa. For the 31-meter cantilever and 147 meter above ground, design and construction coordination is vital. Construction technique dominated the design. For the South Tower, stability of the Leaning Tower is accomplished through the interaction of the reinforced concrete inclined side frames and vertical central shear core. I guess the group would be visiting the site after the seminar. The third example would be the Magnolia Waterfall residence. The total height of the tower is 315 meters. The width of the building is just only 20 meters. So the aspect ratio is just only 15, which exceeds a typical range of ordinary high-rise building, considered to be very slender and therefore very vulnerable to the wind force effect. Wind tunnel technique was used to capture a more accurate design wind forces and design parameters. Design criteria to satisfy as shown on the slide. To achieve those criteria, special structural system consisting of wall-shaped columns and large central lift core, together with the outrigger beams, were used. With outriggers at two levels, we have managed to reduce the lateral sway to the limit. Therefore, damping system was not needed. The fourth example, spherical structure with diagonal skin frame. The sphere is 90 meters in diameter. It can accommodate one football field. It is elevated to 30 meters above ground and supported by two mega columns and one rectangular service core. This building required extensive and advanced precision of structural analysis to ensure the stability. Certainly, construction technique dominated the design. The building contains column-free spaces with several long-span structures to accommodate auditorium and atrium hall inside. The fifth one, Bangkok Art and Cultural Center. This project contains several structural components in shell and plate forms, since it is art and cultural center. This project demonstrates that reinforced concrete structures can be used in a very irregular forms as well. A sixth example, the new Thai Parliament. This project also contains column-free spaces with several long-span structures to accommodate auditorium and atrium hall inside. The building crown is classical Thai architecture in which structural form of Thai temple has to be implemented. Structural design for blast resistance has also been introduced through the use of composite column. The building should not undergo progressive collapse in such incident, since it is to be occupied by the politicians at large. The seventh example is the structural modification for meeting room. The architect required that the central column be removed to accommodate larger span and column free space for the meeting room at the ground floor. Therefore, new transfer beams were installed to achieve the 16-meter long span instead of 8+8 meters, and also supported the existing floor above. The transfer of the existing building weight to the newly installed transfer beams is crucial and normally gets ignored by inexperienced engineer. Therefore, it was required to jack up the existing central column load before cutting the column, and then release the load back to the newly installed beam to ensure full transfer of existing weight to the new structure. In conclusion, identifying all the problem statement or complications that could happen in complex structure and architectural forms is the key. Successful structural engineer must be capable of visualizing the design process from conceptual design until the completion of the construction. That is all. Thank you.